Alright. So bubble sort is a simple sorting algorithm in which we compare two adjacent neighbors, and if the left neighbor is greater than the right neighbor, we swap them. We do this throughout the entire array. For the purpose of bubble sort, we have an unsorted array, and towards the right side of the unsorted array we have a sorted array. So in the beginning, the sorted array is assumed to be towards the right of the last element, which is right now empty. After every pass, the size of the sorted array increases by 1 and the size of the unsorted array decreases by 1. After every pass, it is guaranteed that the next greatest element reaches the rightmost part of the unsorted array. So now we begin with the sort. We begin with the first pass. So what happens in the bubble sort is that you begin from element at index number 0. We compare this with that at index number 1. Since 4 is greater than 3, we swap them. Now we go to index number 1. We compare this with index number 2. Since 4 is greater than 2, we again swap it. Now from index number 1, we go to index number 2. And then we compare this with index number 3. Since 4 is greater than 2, swap. Now at index number 3, we compare this with index number 4. Since 4 is less than 5, we do not do anything. So now our unsorted array is towards the right of this, which means that, the sorted array is towards the right of this, which means that 5 is a part of the unsorted array, of the sorted array now, and this is the unsorted array. So now we only need to make comparisons till the end of the unsorted array, which is till element number 3. Alright, so now we again begin from element at index number 0. It is 3. Now we compare this with the element at index number 1. Since 3 is greater than 2, we swap. We compare this with the element at the next index. Since 3 is greater than 2, we swap again. Now comparing with the last element of the unsorted array, 3 is less than 4, so we do not do anything. Now this is the sorted array and this is the unsorted array. So again we begin from index at element from the element at index number 0. We compare 2 with 2. Since 2 is less than 2, nothing happens. Then we move on to index number 1. We compare index number 1 and index number 2. Since 2 is less than 3, nothing happens again. Alright. So now that we have traversed the entire unsorted array, we find this to be the next greatest number, and this is the part of the sorted array. Now since this is the sorted array and this is the unsorted array, we only need to make comparisons till here. We again begin from element at index number 0. We compare this with the element at index number 1. Since this 2 is equal to 2, nothing happens again, and a sorted array increases. Now since only one number is left, this is already sorted, and this is our final sorted array. One thing that we need to notice is that bubble sort is a stable algorithm, is a stable sort, which means that if two elements are equal in value, then their order in the sorted and the unsorted array is the same. We can see this by the order of 2's. Even in the unsorted array, the black 2 was before the red 2, and in the sorted array also the black 2 is before the red 2. So bubble sort is a stable sort. Now for the time complexity, we observe that t of n is equal to t of n minus 1 plus n minus 1. This is for the worst case complexity. This is simple because for an array of size n minus 1, if we assume this to be sorted and bring a new element, n minus 1 comparisons need to be made for the new array of n elements to be sorted. And t of 1 is equal to 1. This is again simple because if we have only one element in the array is already sorted. Solving this, we figure out that t of n is to the order of n square. So the worst case time complexity of bubble sort is of the order of n square.